My name is Adam Rothschild, mortgage analyst. I've been at 1010 Data for about 4 years. Many of you I've dealt with through email or WebEx or phone conversations. It's very nice to see your face. So this presentation is going to be advanced or maybe new XML features that are on the platform. And there's a lot of new stuff that you've probably not aware of, and the goal here is to go over these new XML tags so that you'll come away at least realizing that there's some new things that you can do on the platform that maybe you never considered before. A lot of you might still be stuck using the legacy code, and we want you to sort of move forward. We want you to start using blocks and some of the new technology. The goal is to make you more productive, more efficient, write better code, write easier to read code, and write less code to do the same thing. And just a note, all of the examples that are in here are going to be available in the folder, as you can see. And some of the examples, you might need to use a beta version of the system in order to get them to work. Also, if some of you are not aware of it, it's a really cool feature is 1010 has its own scheduler. So if you don't have access to it, let us know, but the way to check is under your ID in the upper right-hand corner. If you're using GUI 1, you'll see admin and then query scheduler. And it looks just like this. It's very simple to use. You would just enter your query in here, typically a block. You start with a base table and you give it some timing parameters and you're off to the races. So the first thing I'm going to go over here is block. Block is a tremendous innovation for 1010. I'm sure a lot of you have already been using it. What it enables you to do is parameterize your code. So the code that you had before, where you had values hard-coded in this case, all you need to do is pass in values, and the code will get expanded. So the New York here will replace the parameter here. Very simple. Blocks can be saved as quick queries. You can embed them in library tags. So this example itself will actually run if you paste it into the XML code. But you could save it as a quick query in library tags or convert it to a def block. And then in order to make it run, you would have to use an insert tag. This example is sort of the same thing, but what we're doing here is showing you some of the packages and the data structures that you can use to pass data around in 1010. So in this instance, we have what we call a comma-separated list, which is basically just a string that has a bunch of commas in it. Here we have a package, which is sort of a named list. And one other thing that we have is a list, which is an array, which we're going to create over here. So in this example, what we're doing is we're converting this string to a list. And once you have a list, you can index it. So in this case, we're taking like the second element of the list. The problem with a string like this is if you go to use it in a select, it's not going to work because you need to have each one of those states quoted with single quotes. So we have a very neat function called QV. And what that does, it works on a list and will automatically correctly quote all of the states for you so you could use it directly in a query. Last but not least is a package. There's numerous ways to access the data from a package. So in this case, we're actually just picking one of the names of the package and we get the relevant value. Signal. Signal is a great debugging tool. We need that when we're working with blocks and parameters. Here's a simple example. What happens is when you run code and you encounter the signal, the code will stop at that point and print out whatever message you want. So it's the way to see what's in parameters. It's the way to see what's in packages and so forth. This is a simple example, but if you can imagine, you're very deep into a lot of levels of blocks, a lot of levels of for, for each, it's very useful to be able to know what is actually in that parameter. So now we also have the do transaction, and that is a major step forward in my opinion, because it enables you to perform API transactions directly through the XML. If you wanted to save tables or save files prior to having do, you would need to either use the API, use 10do, perhaps use PowerLoader, or like if you wanted to save a simple table, you could do it right from the GUI. But with do, you can do all those things right within the XML code. You can also create segmented tables, which you haven't been able to do before from the GUI. So very, very powerful, and when used in conjunction with the scheduler, it enables you to do everything you need to do in certain cases just on the platform. There are two forms of do. The older form, in this case, where you have to say the action is equal to API and provide XML tags for the path. I believe the only reason it's still around is because not all the transactions have been mapped. In this case, you can just put in all the data, all the inputs as direct arguments. So if you go to the reference manual, you'll see a whole bunch of these different do transactions in there and see which ones are useful to you. Just a side note, what is segmentation? Many of you have run G functions before and they don't work. And you say, well, why is my G function not working? And we say, well, your table is not segmented. And what that really means is that all of your grouping, for example, if you're grouping by pools or loans, one pool or one loan, the whole time series has to be on the same physical device. That's what's important about it. Because 1010 runs in parallel, and if your loan is distributed amongst many machines, you can't run a lot of these G functions. You can't go through the full history of the loan. So that's really what segmenting is doing. And it's also a way of indexing tables so that if you have segmented tables, things should link much faster and be more efficient. And there's two different types of segmentation. To me, there's not really that much difference. In just one case, the sort seg adds an additional sorting constraint on the group parameter. So here's our first example of how you could use do, and you could basically just paste this right into the scheduler. So these are two save file transactions. They're about as simple as you can get. And you're saving two different files to FTP, the weather.test and baseball.test. And you can actually clear cache in between. So if you've got big stuff going on and you need to get rid of, clear up the memory, there's another action for you to run. For the purposes of the next couple of examples, I've kind of hacked together a sleep function. So this one, based on these inputs, sleeps for about 30 seconds. You could play around with the inputs and get the type of sleep that you want. And what we want to do here is check to see if the table has updated. So it's important to many of our customers who are waiting like on the 4th business day for information to come in from the agencies, and they want to know if their tables are ready yet, so they call. But you can actually build all this right now into the scheduler and have the stuff run when the table is available. So this is the first part of what you're going to be doing. You're going to loop for some arbitrary count. You're going to sleep. You're going to set a control parameter the first time through. So if the control parameter is set, you're going to continue looping through the code. And here's the meat and potatoes of what you're doing. First, you're doing a dbupdate. So a dbupdate is going to take that table and make sure that it's in its latest form. Prior to this dbupdate, you would have to log back in to the system to get the latest version of the table. But now with dbupdate, you're able to update the table in place. So once you do that, you then do a gettab, which is another API operation. And this returns parameters about the table information. And one of the pieces of information that it returns is when was the last time that the table was updated. So if you first pass through, you save the results from that, and then in subsequent runs, you just compare the latest with the latest update with what you have saved. And if it's different, you know your table is updated, you could set your OK parameter back to 0. So that means you won't be going through this anymore because there's no way to gracefully exit the 4. You have to keep going through it. You set your sleep parameters to 1, so it doesn't really sleep. And instead of having a signal here, you could do whatever it is that you need to do. You could save a table, save a file, whatever. This is a slight variation of that. And now, in some cases, you don't really want to depend on whether or not the table itself has updated. You want to do a query. You want to run a query on your table, and from that query, you're going to say, is my table updated? And that occurs a lot in mortgage world because the table can update multiple times, but it might not be the update that you're interested in. So in this case, we run a query. We want to find out what's the max factor date. We save the max factor date in a value, and then we compare the max date with the original one. If that exceeds it, then we know the table is updated. And the same thing, we can run our operation. It's good to go. It's good to go. It's good to run our cohort analysis. And the third variation in this case is what happens if the table doesn't exist at all? So there's no table there. So the dbupdate command will also work on top-level folders. So when you use dbupdate on the top-level folder, if that table somehow gets added, it's going to show up. So what we're doing here is we're taking this path, we're looking for this table, we're dropping the test table part of it, so we're just looking at what the folder is. We're looking at the folder itself. We're doing a dbupdate on that folder. And then we're querying to see if that path exists from the results of this directory. So directory is a command that gives you all of the information for a given folder. It'll give you subfolders and it'll give you tables. So when you have that information in hand, you can check your return parameter here, this OK. And if this XOK is 1, then you know the table is there, and then you're good to go. You're good to run your queries. So this is a defop tag, and it does exactly what it says. It lets you define an operation. It lets you create your own tag, basically. The nice thing about it is less code. You can repeat the code, so if you might have something much larger than this, and it's readable. So you could give it an intelligent name, and you can see exactly what you're doing. So what we have here is just one date, a one input parameter, which is a date, and a simple function to give you the week num of the year. What's the week num of the year? And here, this is how you run it. Just week num with the year, and you get a value back. And the defops you can save in the same manner as you save blocks. You can put these in your library as well. Here's another version of defop, and what we're ultimately trying to do here is just build a string, a pipe string with a bunch of ors. So here's the ultimate output. Once we expand the code, this is what it's going to look like. This set has two forms. This is the long form of set, and what it's doing is it's putting the results into this parameter, select expression. So we start with the rows that are input. So rows are these three values. We do a for each, so we go through for each one. If it's not the first case, we're not going to add the pipe after it, and we're building this string. And then at the end, we just have this value here, because we do a select value equals the select expression right here, which is what we built in this set. How many of you have used PowerLoader? If you've used PowerLoader before, with this example, it's the same thing. It's PowerLoader right in the XML. And you have this familiar spec file, similar to what you might set up with PowerLoader. And all you really need to do is supply the name of the file that exists on FTP and just a path for your target table where you want to save it.
Does this always have to be saved in FTP, or can it be directly from a local directory?
For this particular example, for the add tab transaction right now that you run on XML, yes, it has to be saved in FTP, but there is an add tab that you could run and embed it like in Python or something like that, which you can use with any file just sitting on your desktop. We also have the ability with 1010 to catch errors. So this is sort of a try-catch situation. What we're doing here is we're trying to do a DB update on a path of a table that doesn't yet exist. And if it exists, if this table does exist, this will succeed, and we set this parameter equal to 1. The set exists equal to 1. But if it fails, then it's going to go into this block and set the parameter equal to 0. And again, instead of having the signal, you can do different things based on whether it succeeds or fails. So for this example, we're using a getData transaction. We're running a query, and we're putting the results basically into a big parameter, into this big table value. And this just shows you how you could use those results. This is typically used for a quick app, but what we're doing in this example is we're taking the name and the ID from the weather stations table, comma, in a table like this, a comma, which is a temporary table, a comma indicates that it's going to be a new column, and a semicolon indicates that it's going to be a new row. So we're just queuing this up, building this big A parameter here, and at the end we're using that A parameter in the dropdown. So we're going to just have a dropdown with IDs as the actual value, and the name of the station as the dropdown is what you're actually going to see. I think you're all going to like this one. So it's no longer necessary when you do a link to actually have columns there. In the past, if you did some sort of tabulation where you came up with a single cell value and you wanted to link that to a big table, you'd have to create like a dummy variable, a dummy column on both ends, and then link on the dummy column. No longer necessary. With this type of, with the new improved link, you can just do something like this and you're good to go. And the real benefit of this is that you're no longer building a worksheet, you're actually linking tables together. So it's a much more efficient type of link. You could also use a function. You could also change things on the fly in links. So how many times have you been trying to link, for example, to an HPI table, and you forget that you've got an MSA in one case that's a string, and it's an int in another case, or you've got year, month, day in one table, and just a year, month in the other table, so you will have to go back and create new columns. In this case, you don't have to do that anymore. You can just write the functionality right here, and again, you're just linking in two tables instead of two worksheets. So we've talked a little bit about insert, where you call a block maybe from a library with insert. The difference between insert and expand is expand allows you to change a global parameter. So in this example, what's happening is we first insert block 3, and when we do that, afterwards we check the value of x. So x is originally 22. We change it to 99. We come out after the insert, and we check x1, and we check the value of x, still at 22. So we haven't changed it. So now we have a different block which kind of does the same thing. You can see it creates the y. Then when we expand it and come out after that, we'll create the x2 column and compare that and create that from the value x. And when we do that, you can see the value has changed. So if you ever need to change the values internal to your internal to one of your blocks, you could use expand. So loop is a really powerful operation that's available through 1010. It's been around for a little bit of time, so I believe a lot of you have been using it. In this example, what we're going to do is rename the values in a crosstab. So a crosstab, I'm sure all of you have used. It's a great feature, and it lets you do things like pivot, like a pivot table. But the naming of the columns is what's the problem, at least to me. So in the old format, you would just have columns named M1, M2, M3, M4. Even though the labels were fine, the column names were hard to use. They didn't mean anything. Now, with the new crosstab, you could save multiple you could do multiple functions within it. And the format is even a little bit different. So the first indicator, the first reference is to what function it is, and the second is what's the column. So what we're doing here is we're using a loop. We're using meta. That's going to be just the name of the package that we're going to get back. And loop does a calculation, a separate calculation, and returns the results from that calculation into the inner portion, the inner part of the loop. And all we're really doing here is we're figuring out, we're looking at our auto data, and we're figuring out in this query what are all the deal names and all the deal IDs. We use gsplice to do that. It puts a comma-separated list of every deal name and deal ID into the two separate columns, and we just take the first value, the first row of that, the first record. Now, in the inner portion, what we're going to do is we're going to use that. So we get back this meta, again, the meta package, and it's going to have two elements, two comma-separated lists, the deal ID and the deal name, and we're building new columns here. We're building new columns, so we're taking column M0, because we know M0 is going to be our balance column from here, and we know M1 is going to be our weighted average column. So we're going to basically name them balance and OCS, and then the var here is produced from this list. It's produced from this comma-separated list of deal IDs that we're going through. So we're producing deal ID underscore balance as the names, and we're actually giving it, what's in there. Is it a balance, or is it a standard deviation, or whatever? And the last step of this is now we want to get rid of the original column. So we can just get rid of the M columns this way. And we're done. We have a whole new set of columns with reasonable names. This is a similar example. This is where we want to flatten out a table. We have a geo table where we have 40 or 50 rows for one month for one pool. And what we want to do is instead print it out so it's all in one row. So again, we do something similar here. We do a tabulation to get the names of all of the states that are out there that that will be available to us. And we again set the record, the number of the row count equal to 1, and that value is passed in the inner portion, and we loop through the states basically. So we have a list of states, and we create this value is state, and then we use an rshift function with that second argument set. So we're now building new state columns. And at the end, we can just, again, eliminate the columns that we weren't interested in, and we can do a check with a row function so we could sum up the %RPB for all the columns that had %RPB in them, and see if that adds up to 100. Issue is another tag that's relatively new, and it enables you to drive the input to blocks from a table. So you could have inputs to blocks as a comma-separated list here, the name of your blocks, and you could have them in your table. So this could be many blocks, many different inputs. You're going to do a selection on it. The portion here is necessary just in case you do a selection and you get nothing from this part. You need to have at least one value, so one value returning from the loop so it doesn't fail. And now what you're doing here is you're building a package on the fly. So the first thing you have, in this case, you're putting everything into the P block. So you're now creating an inputs package. So you're setting the block, which is coming from the table, P block as the block, and then you're taking the params list, which is this string right here, and you're doing this. We did this already before. We're creating a list, an array out of it, and then we're going through the array and we're breaking it out so that we separate it across. We use the equal to separate it, and we're creating an additional part of our input. So we have a tag and an attribute, and then we keep adding that to the package. So the input package has the block name, and it has a whole bunch of these A equals B, that type of thing. And what we wind up doing at the end is just using this insert. We use the issue tag. The tag is insert, and we input that package, and that calls the block. So that enables you to call multiple blocks with multiple types of inputs in it in a reasonable way, being driven from a table. Another tag that's available is return. So this will return, in this example, we have a block called X, and we're just returning this package. So in this part here, we call this block here, and then we return the package and we put it into value R. And the neat thing that you can do is you can actually save this package. You can save the XML as a column in 1010. And you can see it looks like this. This is what your actual table looks like. And the useful thing about having something like that is it's kind of like a case, a switch, or an if statement. So you can have a column with different inputs, and finally you're going to drive the Z column based on this package. So here we'd input C, and you would get the value 3. But you can imagine doing that for a larger table as well. So in this example, what we're doing is we want to view our files on FTP. Normally, you would have to go to FileZilla or do an FTP command. You could build a simple application that does it. All it is do action is equal to files, and the table value is the name of where you're going to store them. And really, what else is going on in here is not that important. It's just taking that value and storing it in the form so it'll show up in a grid, so it'll show up in a table. But you would actually, just by running this, have a list of all of the files that were on your system that you could use. This is another one that's simple, but I really like it. I think you will too. Traditionally, G functions, the second argument, and the argument that you're doing the measure on had to be columns. You had to go out and first create these columns before you could use them in G functions. Now, you can save a couple of steps and embed the code right into the G function itself.
That's pretty good.
And in this example, what we're doing is using the getquery. So this actually lets you look at stuff that you've saved as a quick query. So a library, for example. So in this case, I've saved this library, this MBS generic library on the system, and I want to see what's in it, and I want to maybe present that in a nice way. So you run getquery, and you get back in this library path variable like a bunch of XML. And now you have the ability with this XML to actually search. So library is going to be the first tag that's encountered because the whole thing is enclosed in library tags. So after encountering the library tag, you can search for blocks. You can search for defblocks, and you can search for defop operations, combine them all together, present them in a certain way, and you can basically categorize your library. And we have a tool coming out that's going to be able to do that, that enables you to write up a lot of information about your blocks and make them more useful. So we covered a lot. Basically, this is it. I'm not going to go over it again. And again, the idea here is to just introduce you to a lot of these new techniques. It's a lot of XML, so maybe you won't understand it all right away. But I think if you take a look at it and work with us, if you have questions, you'll be able to use a lot of this stuff. Some of it I think you'll find very useful, in particular the do transactions if you've been doing a lot of stuff off platform now that you can do everything on the platform. All right, so I guess we've got about 12 or so minutes, and if anybody has any questions. Yes?
Are there any plans to be able to cross-tabulate on multiple columns?
So if you looked at that example, that's already doable.
Okay.
So that's what I was discussing. You get the functions come back as M0 column, M1 column, M2. So now you can cross-tabulate on multiple columns. In GUI 1, there's no way to set it up with the GUI. There's no way to actually do that. But in GUI 2, you do have the ability to set that up properly and add multiple columns in there. And so we have, I don't want to go off top, but we do have a separate, a new version of the interface that's available, and you could use it, you could try it. So all you'd have to do is sign into like 1010 data prime dash latest, and that will give you the new GUI. And you can see there's a whole bunch of different functionality there. Some of it you like, some of it maybe you won't like. So, but it's definitely available for you. And if you want to give it a try, let us know. Yes.
You mentioned something about like testing the data itself before loading it, like kind of seeing if it is like before we kind of go into the power loader and kind of define everything. Is there a way to check for errors in the data itself? Like suppose I'm seeing a data set which is showing up in like a date format, but somewhere along the line it kind of changes, or it is in a different, it's in a text format in that column. Is there a way to kind of see such errors?
Yeah, so the question is, can you actually check the data sort of before you've loaded it into the system? And the answer to that is, I believe, no. Unfortunately not. So one of the possibilities of what will happen is if you don't have this set up correctly, you'll either load the data, and then once you look at it, it will look incorrect. Number two, it'll just outright fail. But there's no way to sort of, with PowerLoader, you have the ability with the spec file to define precisely how you want that data to be represented. So you don't necessarily need to have the system decide for you whether it's a text field or an integer or a float. You would specify it. You could specify every last detail about those columns. But still, if you have like an awry data set, like some values in there that are bad, they'll either cause the load to fail, or those values might show up as NA.
So there's no way to know that beforehand, like before we...
Before you actually load the system, no. Yes?
For the FTP, you just show that you can build like a quick app and see the FTP files.
Mm-hmm. Yes.
So any way to build like a quick app and let the users upload their own files instead of...
Well, that was mentioned earlier. The question is there any way to include an easy way for the users to upload files? And the answer to that is yes, but you might have to wait a little while for it. If you use GUI 2, there is, and it was talked about at the beginning presentation, if you use GUI 2, they're working on a very simple way to add files from your desktop right up into 1010. A drag and drop where you just drop the file into this widget, and then it'll just get uploaded, and you don't really have to do much. It's intelligent enough to interpret what fields you have. So GUI 2 is built completely with 1010 widgets. So that widget itself will be available for you to include in your quick app. So you should be able to include that and have that functionality. Yes?
Will the upload mechanism allow appending data as opposed to overwriting a table?
Yes. So the question is, can you append as well as upload to a new table? Yes, you have the option typically to replace the data or to append the data. Yes. Right.
I have two questions. You showed a code of flattening a table.
Mm-hmm.
I think there is an existing command or a tag called transpose.
Yes.
The reason that you showed your way because it's more flexible than the transpose. What's the difference?
I think it's actually, the question is the example with the flattening of the table similar to the transpose operation? A couple of things about the transpose, as far as I know, is that it won't actually give you the same format as flattening the table. And the second thing is it won't work on really large data sets. So you could do a transpose on maybe 1,000-row table, but if you tried to do it on the geo table, it wouldn't work.
You mentioned thing about like updating table updates. like, one of the things, at least in the non-NC RMBS database that I do is, like, I have a predefined query. I kind of go in and check whether new deals have been updated to that or not. Just adding new deals
Mhm.
for the remittance date. And then I have my task scheduler for all the other subsequent queries to run once that is done. Is there a way to kind of do all of that in like sequence, like, check if it's updated, then go to the next task scheduler, if they're done, then go there, and so on and so forth?
Yeah, so the question is, can we do in sequence various checks on the data to make sure that all the data that we expect to be there is there before we run big queries off of it and send it out to our managers? The answer to that is yes. All of those do transactions run asynchronously, so one will run after another. So you would perform your check, typically with what you've suggested. You could save the list of deals that you're expecting or whatever, and then do a calculation on them from one of our files and see if that, so find all the deals with this month's issue date, for example. And if that number is low, or if it doesn't match what like you might have something from Bloomberg that has all of the new deals in it. And if we don't have that yet, your operation would fail. So you wouldn't perform your operation. You wouldn't distribute the report yet until you have everything there. Hi.
So it's maybe more high-level question, but are you planning to just get rid of XML and do some normal programming language? Because ultimately, for those of us who used to think that Python or C++, this is still ugly. I mean, the need to do will be and all that type of extra stuff. I mean, it's annoying, but it's work. And it seems like, just looking at the example, the more features you add, the more ugly it becomes from just pure computer science and programming perspective. Do you have any plans to just revision this and put it to some kind of different type of language or interface or something like that?
So the question is, will there be some other type of interface available other than the XML?
Or doing things, I mean, you have user level interfaces, so this is about for programming.
Right. So you would like to write select statements and so forth.
Like code.
Right. So there is the ODBC. There is the ODBC driver. So you can run many things with the selects and inserts that you're used to. However, if you wanted to use a special 1010 function, like a G function or something, then you still have to resort to the XML. You have to embed some XML into the query itself. I don't envision the XML going away because everything sort of boils down to the XML. But what I do envision is that the GUI is going to be good enough so that you don't even have to worry about it that much. If you use GUI 2, that's sort of the lines that it's taking, where you can just use a bunch of drop downs and self-assisted widgets that are going to tell you basically what to do. What are your inputs to this function? So it may not get rid of the XML, but I think it's going to make it more palatable for you. Hi.
I have one more question. Relating to the new functionality of the G function, where you don't have to use a column,
Mhm.
but you can just define whatever the selection is. That's basically taking 2 steps into 1 step, right? You don't have to create that column variable anymore.
Correct.
Is there like a speed thing? So if before it was 2 steps, and now you can do it in 1.
Is that going to be more efficient? The question is, using the G function in the new manner presented, is that going to add efficiency? The answer is I don't honestly know the answer to that question. My suspicion is that there may be a little bump, but I don't think it's going to be, a huge bump. Where you have the efficiency is just less lines of code, and to me, more fun to write. I always found it annoying to have to do that, and a lot of times I found myself forgetting it and doing that anyway and having it fail. So it's efficient in that manner more than time saving, I believe.
And does that G function integration, does that support like only mathematical operations, or can you put like G functions or R functions in there as well? This is like basically anything you could put in another.
So you can have G functions that that use other G functions, and so your last column, whatever it is that you're doing the measurement on, can be another G function. So that a lot of our customers do that. The one negative thing I find about that is inefficient, because you're doing you're going up and down the whole time series for a loan, and then each time you do that, you're reevaluating the G.
You're gonna put like if-thens in the
Yeah, well,
in your G function.
Yeah, you can do that, but the way the 1010, like the 1010 if is an inefficient function, because unbeknownst to you, it actually evaluates all cases. So it doesn't end the first time you use it, it'll just continue to evaluate. There's been talk of improving that if, but if is something that you would like to avoid if you're trying to build efficient code.
Because that could be a double-edged sword if you open it up to any
Yes.
kind of operations in there.
Yes, yes, yes. Okay, any last minute questions?
We need to move on to the next.
Okay, I'm very sorry. Thank you very much for attending, appreciate it.